Hello, I'm Ray of the Ray Code. In this video, I'll be studying the design pattern known as Abstract Factory. I'll be using C# in this video. I use other programming languages like PHP, Java, C++, but for this video, I'll be using C#. I provide a list of reasons why a C# programmer would want to study the design pattern. I give you a UML that it was given by the game for. I provide some sample code so you can play around with yourself. You can also find that code at my GitHub site and also at my website, theraycode.org. I provide a SWOT analysis for the pattern. I have put some timestamps in the notes so you may navigate to the sections that you interest most. Follow me on X, Facebook, LinkedIn, wherever you can find me. Leave a comment. Tell your friends the record is awesome. C# developers should study the Abstract Factory pattern to enhance their software design skills and create more robust and flexible applications. Here's why. Modularity and separation of concerns. Abstract Factory encourages modularity by isolating the object creation code from the rest of the application. This separation of concerns makes code easier to maintain, test, and understand. Flexibility and extensibility. By relying on the abstract interface for object creation, the pattern allows you to introduce new families of objects without modifying existing code. This makes your application more adaptable to future changes and new requirements. Code reusability. Abstract Factory promotes code reuse by promoting a common interface for creating related objects. This reusability can lead to more efficient development and less duplication of code. Consistency and compatibility. The pattern ensures that objects created by a particular factory are consistent and compatible with each other. This is especially beneficial when working on projects where maintaining consistent object hierarchy is crucial. Improve collaboration. Understanding and applying patterns, including the abstract pattern, can improve collaboration among developers. Design patterns provide a shared vocabulary and solutions for common design problems, making it easier for a team member to communicate and work together efficiently. Quality software design. Abstract Factory, like other patterns, encourages best practice in design and promotes modular maintainability and scalable code, leading to higher quality software products. Learning design principles. Studying the Abstract Factory pattern introduces developers to important design principles such as abstraction, encapsulation, and separation of concerns. These principles are applicable not only to the pattern itself, but also to various aspects of software development. In summary, C# developers should study the Abstract Factory design pattern to gain a deeper understanding of software design concepts and apply those concepts to create more flexible, modular, and maintainable applications. This knowledge can lead to improved code quality and more efficient collaboration within development teams. UML. Abstract Factory declares an interface for operations that create abstract product objects. Concrete Factory implements the operation to create concrete product objects. Abstract Product declares an interface for a type of product object. Concrete Product defines a product object to be created by the corresponding Concrete Factory. Client uses only interfaces declared by Abstract Factory and Abstract Product classes. Collaborations. Normally, a single instance of a Concrete Factory class is created at runtime. This Concrete Factory creates product objects having a particular implementation. To create different product objects, clients should use different Concrete Factory. Abstract Factory defines creation of product objects to its Concrete Factory subclass. Hello, I'm Ray of the Ray Code. In this video, I plan to give an example of the design pattern known as Abstract Factory. I will give you an example of the Abstract Factory design pattern that is found under the Creational Design Pattern that has been presented by the game for GOF. I'll be using C#. Each class will be placed in its own file and created in order that avoids dependency issues. We start by creating an interface we call iAbstractPart_A inside this interface structure, and in here we require the user of this interface to have a use method. With this interface, we define two different types of other interfaces. One for a class called ConcretePart_A1, which will be extended with the AbstractPart_A interface, thus requiring this class to have a use method. We can use code auto generator by implementing the missing members action, and we replace the throw error with a message that says using ConcretePart_A1. We create another class called AbstractPart_A2. We will now create what I call the B series. We start with the Abstract Part B. This will be a B series factory, which will also require a use method. So we create a concrete product in similar fashion and return the string using concrete product B1. We do the same thing with a concrete B2 object. Now let's create our Abstract Factory interface. We will require the use of this interface to be able to return a create product A object of Abstract Product A type. We do the same for a concrete product B type. Now let's make the Concrete Factory 1 class. Concrete Factory 1 will be extended with the Abstract Factory interface. Of course, we need to implement the missing methods. We get a Concrete Product A method and a Concrete Product B method in which we will need to define. We return a new Concrete Product A and a new Concrete Product B. Let's create a Concrete Factory 2. Concrete Factory 2 will also be extended with the Abstract Factory interface. In our method, we return a Concrete Product A2 and the other we return a Concrete Product B2. So now let's go to the main method in our program. We create a Factory 1 from which we return products A1 and B1, of which we evoke their methods create product A and create product B. We execute the use method on both. We do the same with Factory 2. And we also execute the use method on both. Our result is using concrete product A1, using concrete product B1, using concrete product A2, using concrete product B2. My name is Ray. Keep coding. SWOT analysis of the Creational Design Pattern called the Abstract Factory Design Pattern in C#. S. Strengths. Encapsulation of object creation. The Abstract Factory Pattern encapsulates the creation process of family-related objects. This promotes a cleaner separation between object creation and business logic, leading to more modular code, flexibility, and scalability. The pattern makes it easy to introduce new product families or switch between them without altering the client code. This is particularly beneficial in large systems where the object creation process is complex and subject to frequent changes. Consistency across products. By using an abstract factory, you ensure that products from the same family are used together, maintaining consistency across the application. Strong type checking. In C#, the abstract factory pattern takes advantage of strong type checking at compile time, reducing runtime errors and enhancing code safety. W. Weakness. Increased complexity. Implementing the abstract factory pattern introduces classic and interface, which can make the codebase more complex and harder to understand for developers unfamiliar with the pattern. Overhead in small applications. For smaller or less complex applications, the abstract factory pattern might be the overkill, introducing unnecessary complexity without significant benefits. Difficulty in extending products. If you need to add new types of products to existing families, it might require changes to the factory interface and all its concrete implementations, which could lead to a significant refactoring effort. Tightly coupled factories. While the pattern decouples object creation from the client, the factory itself is tightly coupled to the product family it creates. This can make it harder to introduce products that don't fit neatly to the existing families. O. Opportunities. Integration with modern C# features. Leveraging modern C# features like generics, async, wait, and dependency injection can enhance the abstract factory pattern, making it more powerful and easier to use. Cross-platform development. With C# and .NET Core bringing cross-platform, the abstract factory pattern can be used to create applications that work seamlessly across different operating systems by generating platform-specific objects. Adoption in large-scale enterprise applications. The pattern is particularly useful in large-scale enterprise applications where different configuration or environments require different sets of related objects. Combinability with other patterns. The abstract factory can be combined with other design patterns like singleton, builder, or prototype to address more complex design challenges. T. Threats. Over-engineering. There's a risk of over-engineering where the pattern is applied to scenarios that do not require such a level of abstraction, leading to unnecessary complexity. Performance concerns. The additional layer of abstraction may introduce a slight performance overhead, which could be a concern in performance-critical applications. Misuse by less experienced developers. Developers who are not familiar with design patterns might misuse the abstract factory, leading to an overcomplicated and difficult to maintain codebase. Dependency on object hierarchy. Changes to the product hierarchy or the addition of new product types may require extensive changes to the factory classes, which could become a meaningless burden. That was my video. I plan to create these videos each week. Follow me on Facebook, X, and LinkedIn. Check out theraycode.org and .com. Leave a comment, subscribe, and like. Be good. The Ray Code is awesome.